This is a video on how to create the roller for our Automata Box project. This one is not too terribly difficult, but there's just a little bit of a hiccup that I wanted to talk to you about before you got started. On the roller, you need to understand where that is. So the roller is what rolls along the profile of the cam. So it will be on the top face is where we'll sketch a little bit. But actually what we're going to end up doing is, because of the way this profile works, we are going to sketch like we did the axle and the crank by starting on the right side and extruding outwards. So I'll tell you what that means. I'll show you what it means here in a second. What I mean by that is we are going to sketch this. It almost looks like a semicircle, but it's not. And the reason I know that it's not is because I have this linear dimension here, 0.0625, and then I have a radial arc measurement. So that's important. We have a linear measurement here provided by the 0.625 typical marking. So what we're going to do is we're going to sketch this semicircle with the little straight nubbin. We're going to extrude it back, and then we have a square that we will extrude a certain depth. So in Onshape, go ahead and create a new part studio. Have your plans handy so you know where these numbers are coming from. We're going to call this one roller. And we're going to go ahead and start our sketch on the right side in for normal. And this time I am going to start with a line. And that line I'm going to start on the origin. And that line is going to represent the top edge of our roller. And the top edge of our roller here is 0.625 typical. So that means that this is a square roller at the top. That means this length is 0.625, this is 0.625, 65, and finally 625. So D for dimension, 0.625. Then I'm going to zoom in so you can see a little better. And I'm going to go ahead and draw on either side those tiny little notches that are 0.0625 on each side. So L for line, drop it down, 0.0625, and then escape out, L for line, and I'm going to see if I can grab, using that predictive geometry, kind of bring that over. Do you see how that's predicting? And get it to set. So now those two sides, even though I didn't dimension, that side is equivalent to that one. That's kind of cool that Onshape does that. Now what I want to do is I want to have a 3-point arc. I'm going to connect from that side to that side, and I'm going to drop it down. Then I'm going to look back at my plans to figure out what that radial measurement was. So 0.3125. So D for dimension, click that bottom arc, 0.3125, enter. So there is my overall sketch, and I'm going to extrude this backwards. So flip it the other direction, doesn't really matter, I guess. But the dimension for the extrude depth comes from this 0.625 typical measurement. So I'm going to make that 0.625, hit enter, and green check mark. Next part of this process is to go ahead and sketch that square hole on the top and extrude it to the depth on our plans. So I have my square here, and I am going to extrude it at a depth of 0.81 or 0.1875. I'm going to go back to my roller. I'm going to right click on the top and start new sketch, then in for normal. And I'm going to start that center point rectangle. Ooh, but there's nothing for me to grab because I constrained the line to the origin instead of having a center point here. So let's see if we can find a center point. And the way I'm going to do that actually is by grabbing a line. And because this is not going to be part of the object, I am going to use a construction line. So this right here, where it goes back from the dots, I'm going to create a couple of diagonals. Those diagonals should give me my center point where I can constrain my rectangle. And see how this one didn't change to a construction line? It's actually an object line. I can click that and then go up and click this little construction toggle, and it gives me what I need. So now I should be able to grab that intersecting point here, and it shows me that this one is the intersecting point because it gives me that tiny little yellow rectangle. So I'm going to go ahead and put a point there. And then I could theoretically go through and delete these lines now that I have my center point if I wanted to. So I have my center point. I'm going to draw my rectangle, and this time the dimensions for the cutout will be 3/16 of an inch on each side at a depth of 1875.1875. So 3/16 inch, D for dimension, 3/16. And then I'm going to use my equal constraint to set that side equal to that side. And then I am going to go ahead and extrude. I wonder if it's not constrained, probably because I haven't defined the distances from that center point here and from the center point out to the side would be my guess. Oh, center point, yeah. So dimension. Let's try that. There we go. So I just had to locate the center, and once I did, then it was okay. But now I am going to extrude that little rectangle, and it is a depth of 0.1875, and it is a remove. So I'm going to click that rectangle again, make sure that it shows, click the green check mark, and we should be golden right there with our roller. So if I put this in isometric view and I hide all those planes so I don't get so confused, then I have a pretty good looking part. Hindsight, I probably could have sketched this a little different or use the origin to my advantage so that this would be constrained on the origin, but we did create the part and it's not too shabby looking.